Hi all, welcome to week number 4 of Intro to Engineering for summer 2017. Boy, this class and summer really seem to be flying by at this point. So I guess the good news, bad news thing is if you're keeping up with the assignments, it's week 4 and there's only one more week left after this week and the pain will be over. The bad news is if you're not keeping up with the assignments, then you've got some real problems because we're getting into week 4. So week 4, the main new topic is thermodynamics. Thermodynamics is a study of heat flow. You will somewheres through your, again, regardless of major, you will somewheres during your 4-year time take a thermodynamics class. We do offer one at Tungsys if when the time's appropriate and you have the right prereqs for it. And strangely enough, I can never remember the prereqs for thermodynamics. I'm not quite sure why, and I'm the one that created the class. Anyways, there's basically three main topics that you'll get in the thermodynamics chapter. The first one deals with the first law of thermodynamics, and if you've taken science anywhere in high school, you probably have heard the first law. It can essentially, it's the energy conservation law, and it can be essentially summarized as, right, energy can be converted from one form to another, but it cannot be created or destroyed. So you probably have heard that one already. The second law of thermodynamics, which will also is in this particular chapter, deals with entropy, right? Basically, entropy means everything is falling apart. It's rusting away. There was a great video that I had that unfortunately isn't there anymore. I think it was James Earl Jones, right? That nice, deep voice. And he basically told you about entropy, and he said, you're going to die, right? That's entropy. Basically, entropy deals with the main, I guess, probably the main sets of problems from this chapter, which is the heat engines, right? So entropy says that heat engines can't be 100% efficient. The only way they could be is at absolute zero, which is an impossible state. And it also tells us that heat goes from hot to cold, right? So if you're inside during the winter time, the cold air, right, is not coming into the house, right? The hot air is going out through the house. So those are the basic topics. The heat engine, you'll see a diagram that looks like this, right? Basically, for a heat engine, you have a high temperature source that supplies heat to a heat engine. What comes out of the heat engine is the work out, right? It does some sort of work, and the heat, right? So the heat discharges to a lower temperature source. You're familiar with heat engines, believe it or not, right? Basically, if you have a refrigerator or an air conditioner in your house, that is a heat engine, right? In that case, we're putting work in, and as we put work in, we're taking heat out of out of the refrigerator box or out of the room if it's an air conditioner. You also have a heat engine if you have a car, right? Essentially, in a car, you've got that chemical energy of either gasoline or diesel fuel, right? You burn that energy, right? That energy creates a high temperature, right? That high temperature brings work out, makes the wheels move on the car so that you can go someplace, and you discharge the heat, right? You've got a radiator on the front of the car. The excess of heat goes into the radiator and gets discharged out into the world. So that's thermodynamics. It's a great chapter. You'll spend a whole semester somewhere along the way learning about it. There will be some thermodynamic questions on the final exam, which will be during week 5, which is coming up next week. The other big thing about week 4 is exam number 2. Exam number 2 focuses exclusively on circuits. Now, don't be overwhelmed when you open up the exam. You're going to see a whole bunch of questions. However, in reality, there are only 4 problems. There is a series circuit, there is a parallel circuit, there is a series parallel circuit, and then there's a resistor network that you're going to have to calculate the total resistance for, and it's kind of drawn a little crazy to try to trick you. I mean, quite frankly, that's what it's there for. So when you see the series problem, take and print it out or write it down and solve for all the current, series circuit, current is constant, solve for the current, solve for the total resistance and all the voltage drops, all the powers, and then you'll have you can answer all the multiple choice problems that deal with that one. Same thing for the parallel, right? Remember that voltage is constant in a parallel circuit. Calculate all the currents, calculate all the power, and do that problem out. And the series parallel one, same sort of thing. Take it out on your piece of paper, do all the calculations out, and then you'll be set. There is no time limit for it, so that's the good news. So that's my suggestion on how you complete it. And of course, there's a discussion thread like every other week, and there's a couple of quizzes that have to deal with thermodynamics. All right, that's it. If you have any questions, make sure you post them in the discussion forum, and I will respond to them. Oh, one last thing. The solutions for the sample exam that were in the discussion for week 3, I posted them on week 4. So please take a look, and again, ask any questions if you have any. Thank you. And we'll see you in week 5.